Alright, student, let's dive into the question. The question says evaluate sec and the integral of sec square x. Now, this question is an example of a definite integral where you have boundaries. As in the case of this, we have an upper boundary which is pi over 4 and a lower boundary which is 0. When you are given an integral with boundaries, it's an example of a definite integral. Alright, let's dive further. To integrate this, first of all, we need to integrate the function sec square x. So when we integrate the function sec square x, we will then get an answer, and after we've gotten the answer, we then input the upper boundary and the lower boundary as the value of x respectively, subtracting that of the lower boundary from the upper boundary. So let's go further. Integrating the value of sec square x, we have it to being equal to, from our understanding of standard integral, the integration of sec square x gives us tan x. So in as much as we've gotten the answer of tan x, we can then substitute the values of pi over 4, which is the upper boundary, for x, and then subtracting also a substitution of the lower boundary, which is 0, as x. So what are we saying to that regard? We are implying tan x, which is pi over 4. So we want to substitute the value of the upper boundary for x. In that case, this gives us pi over 4 minus tan 0. So when you have a value in pi, an angle in pi, that draws your attention to an angle in radians. So you may want to fine tune, or you may want to tune your calculator from degrees to radians if it's not in radians. So, and we know the value of tan pi over 4 gives us 1, and then that of the value of tan 0 gives us 0. So at the end of the day, 1 minus 0 gives us 1. So integrating sec square x with boundaries pi over 4 and 0, our final answer becomes 1. That brings us to the end of that question. Alright class, see you next class.